Ever wonder what it felt like to fly from New York to London in under 4 hours? This isn't science fiction. It was real. It happened daily for nearly 3 decades. Most airliners today take about 7 to 8 hours to cross the Atlantic, but the Concorde did it in 3 hours and 30 minutes, cruising at over 2,100 kilometers per hour, faster than a rifle bullet, higher than most military jets. This aircraft wasn't just fast, it was a marvel of supersonic aerodynamics, precision propulsion, and systems engineering. In this episode of Everyday Engineering, we'll explore how the Concorde was built, how it worked, why it was retired, and where supersonic travel goes next. The story began in the 1950s, the dawn of the jet age. Britain and France, once rivals, joined forces to create a passenger plane that could fly faster than sound. The goal cut transatlantic flight times in half. In 1962, the Concorde Agreement was signed. The name came from the French word for harmony, but the project was anything but simple. Concorde's airframe was built for speed, and speed alone reshaped everything we knew about commercial aircraft design. Its delta wing wasn't just aesthetic. It offered a rare combination of low-speed lift and high-speed aerodynamic stability. Without complex high-lift devices like flaps or slats, Concorde could still land at high angles of attack without stalling, essential for airport performance. But it came at a cost, a landing speed near 190 knots, demanding robust brakes and long runways. At Mach 2, Concorde's long, needle-like nose sliced through air efficiently, but blocked the pilot's view on approach. The solution? A hydraulic droop nose that could tilt downward by 12.5 degrees. A retractable visor sealed the cockpit for cruise, then slid down for landing visibility. A simple idea, executed with exquisite precision. Concorde's engines were built from military DNA. The Rolls-Royce Snecma Olympus 593, a twin-spool turbojet adapted from the Avro Vulcan bomber. Each produced 38,050 pounds of thrust and featured reheat, or afterburners, injecting raw fuel into the exhaust to boost power. Critical for takeoff and punching through the sound barrier. But at Mach 2, air doesn't cooperate, so engineers created variable geometry intakes, mechanical ramps that decelerated supersonic air to subsonic speeds before entering the compressor. Without them, the engines would stall. This system turned Concorde's inlets into aerodynamic computers, compressing shock waves to feed the beast. Flying at Mach 2.02, Concorde's aluminum skin heated to over 127 degrees. The aircraft expanded by up to 10 inches in length. This wasn't just anticipated, it was engineered. Expansion joints and flexible wiring absorbed the thermal shift. Even the jet fuel served double duty as a heat sink, channeling warmth away from the skin and electronics. Supersonic balance couldn't rely on traditional trim tabs. Instead, Concorde shifted its mass. An onboard system moved fuel between 11 tanks during flight, actively managing the center of gravity as speeds increased. At takeoff, the CG was forward. In cruise, it moved aft. This minimized control surface deflection and reduced trim drag, keeping the aircraft perfectly aligned with its shockwave envelope. Concorde flew not just on thrust and lift, but on active weight redistribution. In 1976, Concorde entered service with British Airways and Air France, London to New York in 3 hours and 30 minutes, flying faster than the Earth's rotation. Passengers arrived before they departed. Champagne, luxury, and altitude. But there were limits. Sonic boom restrictions banned supersonic travel over land. Concorde's high operating costs and limited routes confined it to a niche, a supersonic icon for the few. July 25, 2000. Air France Flight 4590 crashes just after takeoff. A stray metal strip on the runway punctured a tire. Shredded rubber pierced the fuel tank. A flash fire followed. All 113 lives were lost. Though technically a chain of rare events, confidence in Concorde evaporated. It was grounded, modified, and returned to service. But the magic was gone. Post 9/11 travel slumped, maintenance costs soared. In 2003, Concorde was permanently retired. October 24th, 2003. Concorde's final commercial flight touches down in London. The end of the world's only supersonic passenger jet. A technological triumph grounded not by failure, but by economics, politics, and time. But the dream isn't over. Startups and aerospace agencies are racing to revive high-speed travel. Boom Supersonic, NASA's X-59, zero-emission propulsion, quieter booms. The tools have changed. Carbon composites, AI aerodynamics, and sustainable fuel. The goal remains to go faster, cleaner, and cheaper than ever before. We may once again cross oceans in 3 hours, but this time, responsibly.